Hello. Today we're going to look at some important COCO classes, NSObject, NSString, NSArray, and NSSet. And NSString, NSArray, and NSSet have both mutable and immutable forms, so we're going to look at that as well. NSObject is the ultimate parent class in COCO, and that's where these methods to allocate memory on the heap for an object and initialize that memory, that object with values, come from. So NSObject contains those methods. Alloc is a class method, and init is an instance method. But those methods we inherit from NSObject. It also contains some classes, or contains some methods to introspect to an object. We can find out if it's a member of a class, if it's some kind of class, if it responds to a particular selector or method. But all of our classes, when we program for iOS, will either directly inherit or descend from NSObject. So the concept of introspection says, I have an object, and I don't know what object it is. And the question arises, well, why would I not know? Well, sometimes you return a pointer to an object from a function or from a method, and we get an object back, but we don't know what that object is. So we need to know if it's an instance of a particular class, and for that we would use this member of class. If it's an instance of a class, or does it inherit from a particular class? And for that, we would use this is kind of class method. And we might just want to know if it responds to a particular method, if it has a method declared on it. And for that, we would use this bool, return a bool responds to selector, and then we would specify the method name that we wanted with @selector in place of this construct right here. So when we return a pointer to generic object, that pointer is called ID. It's already a pointer, so it's important to see that we never use ID star, because that would mean a pointer to an object, which is hardly ever what you want. So that caution for you. NS strings come in two varieties. They can be mutable or immutable. The immutable variety, the variety that we can't change after it's declared, is called NSString. NSMutable string allows us to make changes to that actual object. Now, you might think, oh, well, I just want to use NSMutable string all the time. Well, that's really not the case. Very often, we will change a string which returns a new string rather than use a mutable string and change characters within it. So actually, we tend to use NSString, the immutable version, more often than NSMutable string. Nearly all Objective-C strings that you'll be working with throughout your programming career in iOS are NS strings. There's a few car star strings, old style C strings left in the runtime, but all of your strings that you declare as a programmer should be NS strings. There's a constant form, which we've already seen, this @ sign, and then the characters in our string enclosed in double quotes. That is an object. That actually is an object. A constant NS string is an object. We can message it, and we'll see an example of that here very shortly. NS strings are also Unicode compliant. We can insert special characters into them, and that's very convenient. Some of the important methods of NSString are give me a string containing this particular string. In other words, initialize a string, and then we usually pass that a string constant. Also, string with format allows us C-style formatting rules, such as are in printf and scanf and C. We can use those style formatting rules with string with format. We might want to return a string by appending a string to another string, and we will often do this. We can even do something like this, which I kind of alluded to in the last slide. We can say set up an NS string S and send hello, an actual string constant. We can message that string constant with string by appending string world, and that will make S equal to hello world. There's also a string by appending format, and there are dozens of other methods on NSString and NSMutableString that you should look up and read about in the class reference for those objects. Again, another pair of objects, NSArray and NSMutableArray, the mutable version and the immutable version. These are the array classes in the COCO framework. NSArray, again, is used more often than NSMutableArray, but both are used. NSMutableArray tends to be a lot more convenient than NSMutableString, so we will see examples of using both of those. An array, as you already know, is an ordered list of objects. These objects have an index, but unlike a C array, those objects don't have to be of the same type, of the same underlying type. We can have a NS string in one location in an array. We can add another index in an array. We could have something else, and that's fine. We can even have an array of arrays, an array of sets, which we'll see in a set here in a moment, and so forth. But in an array, every object has an index. That index is declared to be of type NS unsigned integer. You'll see NSU integer here in just a moment. But the index is zero-based. In other words, the object at the first position in the array has an index of 0. When we initialize array, we very often use a list of objects. We type that in, and that list of objects has to be terminated by a nil. So some important methods. This initializer array with objects gives us back an array, and it's a nil terminated. It takes a nil terminated list of objects that I referred to at the last slide. Count is a very important method. Count gives us the number of objects in that array. Recalling that arrays indexes are zero-based, count is going to return one more than the index of the last object in the array, just like it would in C. And if you programmed in C, you're very familiar with that kind of coding. Object at index, that returns the object for a specific index. Here's that NSU integer type that I was talking about. Then we often sort an array using a selector. A selector is just another name for a method. So we'll use a method that is already defined on NSArray, or we can define our own method, our own sorting method, and do that. But it's most common to use with an array of NS strings. Something like this. We declare an array, a sorted array, and we obtain that sorted array by sorting the unsorted array using a selector. And the selector most often used is a predefined selector for us, case-insensitive compare. We can also use case-sensitive compare, and there's some other selectors too. And you can read about all of this and all of the NSArray methods and mutable array methods in the class reference. I encourage you to do that. NS sets and mutable sets. This is a little bit different than something you might be used to in C. A set is an unordered collection of distinct objects. Now, we can throw the same object at a set all day long. If it is already in there, it will only have one distinct member of that object. So we use this when we want a group of objects where each one is unique and where the order of that group is unimportant. There are some important methods here. We can obtain a set from an array. That set will throw away all of the non-unique elements in that array when we do that. We can obtain an array from a set. Sets are unordered. The order of the elements in the array that we obtain with this all-objects method will be scrambled. There is no inherent ordering. Of course, then we can sort that using a selector, and that would be fine. we can obtain any object from set, and that'll give us a random object. It'll give us a object that is returned at the set's convenience. It really isn't random. It is going to return an object that the set finds convenient to return to you. Normally, that object will be the same, but you can't count on it from run to run. And then NSSet and NSMutableSet also contains methods for doing set operations, for finding set intersections, whether one set is equal to another set, finding a subset from a set, and things like that. There's also another object, or another class, called an NSCounted set. And this is pretty nifty. You can, again, you only have a group of unique objects within an NSCounted set. But if you send an NSCounted set, or if you add a new object to that counted set that already exists in that counted set, it will add one to that member's count. So there's still only one instance of each distinct object within a counted set, but now there's a count associated with the object. We can make one of these from an NSMutableSet or an NSSet or an NSArray. The count method still returns the count of unique objects in the set. The way we get to the count of each object within a counted set is we use this countForObject method. So I'd like you to take a look at the documentation for iOS 5 on these objects that we talked about today. And also, I would like for you to read Object-Oriented Programming with Objective-C that's also in this documentation in the organizer in Xcode. Now, as I promised, we were going to extend this calculator application, and I've done a little bit of extending. There's still some problems with it, and we're going to continue extending it in our next few presentations. But I want to look at the calculator viewController.h file. What I've done is I've gone ahead and added a property for our model. I've created a calculator model. And the way I've done that is I've gone to File, New File, and then used the Objective-C class template and made a subclass of NSObject and called it Calculator Model. Now, we'll look at that model here in a moment. But what I've done is I've set up a property, a strong non-atomic property called calc that will be an instance of Calculator Model. I've also got a couple more actions. I've got operation pressed, a button, and equal pressed, also a button. And when we look in our zip file, you can see I've added one operation and one equal button. We look at the model. I've got three properties. I've got an NSMutable array that I've declared to hold my operands. And right now there's only two operands for any operation. I've got a NSString that I've declared called pending operation, and also an NSSet that I declared called allowed operations. I've also set up a method called init, a method called set operation that returns nothing, that takes a parameter of what the operation is, and also a method called calculate that will calculate the value here in our model. Now, our model knows everything about the data, but it is instantiated by the controller and knows nothing about anything else. So I've taken here and written a new init method. Now, instead of just using NSObject's init method, I am overriding that method, but I do want to call NSObject's init method to make sure that everything is initialized correctly. So I return self from calling super init, and I check and see if that worked. If it didn't work, we've got a very serious problem that that is going to require you to find out why that did not work. But if it did work, we're going to do some initialization here. We're going to set up allowed operations, and all we're doing is taking an NSSet, which is allowed operations, and creating a set with objects, and the only object in here is a plus. The only operation we're going to support right now is a plus. Now, this is a list of objects, and it is nil terminated, just like in an NS array, and we talked about that. In fact, we have a self operands, which is an NS mutable array that I'm allocating, and initializing with objects 0 and 0, and of course I have to add nil to the end of that. At the end of this, I return self. Now, if self equals super init, if the super init fails and this self is nil, this will return nil, which is fine. Again, you want to check for that, because if NSObject is unable to initialize calculator model, your program has some fairly serious faults. This set operation method simply takes a string, and if that string is a member of the set allows operations, this contains object, then we can put that into pending operation. Otherwise, we want to log out operation is not defined for that operation. And then calculate simply takes the two values in the operands array that we are not seeing how to set those up yet, but those two values, converts them both to floating point numbers, calls them op1 and op2, and then we have another number float result. And we check and see if the pending operation is equal to this plus sign, then we add them and return the result. We return the result as a string. And here's why. Remember, our model deals with the math. Our view controller, on the other hand, deals with the view. Well, the view is all strings. So it's a good practice to set these things up as strings and then let the model do the conversion back and forth. Here, remember, we have this calc, and what I've done is overridden the I've overridden the getter. If we attempt to get calc and calc doesn't exist, go ahead and initialize it, and that's what I've done here. Remember, this init value, or this init method, sets up some values inside calc, and then we return it. If it doesn't exist, if it does exist, it doesn't matter. We're just returning the calculator. In addition to the digit pressed, I've also defined operation pressed and equal pressed. Operation pressed sends the operands array at index 0 with self-display.text. Sets that into that operands array in the model. And remember, that array is declared here mutable array. Then it clears the display because that's what we want to do. And then it sets the operation to sender title label.text. And remember, the operation is that pending operation that we set in the calculator model. Pending operation equals operation. Equal pressed does the same thing for the second operand, our object at index 1 with self-display.text, and then it calls calculate, because now we have a pending operation, we have an operand 1, and we have an operand index 2. And so when we run our application, we will see that we can do a very simple calculation. We can add two numbers. And we'll just try that. And there we go. There's still a lot of work to do on our calculator, but we are getting there. Thank you very much for your attention.